It's Pre-Calculus 5.3, Day 4. And we're going to look at solving equations that have multiple angles. And so the argument in here is a multiple angle. If you go back to graphing, if you remember how you found the period in the key increment, for sine, the period is 2 pi, but when you divide by b, you end up with pi. And so when this is multiplied by a number bigger than 1, you get a horizontal shrink. The period shrinks, and you actually end up getting the full period of sine by the time you hit pi. Oops. That's a terrible picture. But anyway, so that's what's happening right over here. This is pi, and the key increment then is 1/4 of pi, so it's every pi fourths. So you're at 0, then you're at 1 at pi fourths, 0 at pi halves, 3 pi fourths, -1, and at pi, you're at 0. And so when I go to solve these, I need to figure out the two angles with the changed period. They're not going to be where they were before. And they're actually then, if you solve from 0 to 2 pi, by the time you get to 2 pi, here they have for what angles is sine of 2x 1/2. They have a line at 1/2. By the time you get to 2 pi, you actually don't have 2 solutions, you have 4 because of the shortened period. Because by the time you get to 2 pi, you've had the period twice. I brought up Desmos, and just here I've got the graph of the normal sine of x. And so with the normal sine of x, we're back to 0 here, and that's your 2 pi. And here we're at pi halves, we're at 1, pi we're at 0, 3 pi halves, you're at -1. And your two answers where sine is 1/2, that's 30-degree reference angles. So pi 6 and 5 pi 6. Sine of 2x in there, I get 4 points. Let's see if it'll do it. 4 points from 0 to 2 pi where the sine's 1/2. So the question becomes, how do I solve these? How do I get these places where I have more solutions than what there is normally on the unit circle? Another thing to look at is if I have 1/2 x in the argument, that's actually going to be a horizontal stretch, and the period is actually 4 pi. And so the solutions for where that hits 1/2 are different than when it was 2x. So that idea of when you have a multiple angle, the period is changing, and you're either getting a horizontal shrink, which causes more solutions in one full rotation, or a stretch, which would cause less. And so this is what's happening in terms of the picture of the graph. Now, how do we analytically solve that? What we're going to do is start by finding the two angles where sine is 1/2. So it goes back to being able to think through the unit circle, and sine is positive in 1 and 2, and they are 30-degree reference angles. That's where you get the y value to be positive 1/2. So the angle is pi 6 in quadrant 1, and it is 5 pi 6 in quadrant 2. And what we're going to do now is we are going to add plus 2 pi n to both of these. So that is representing all real solutions. That's representing all real solutions. And then we are going to divide by 1/2 all of that. And this becomes pi 12ths. And 1/2 of 2 pi n is pi n. And this is going to be where n is an element of the set of integers. So on the other one, dividing by 2 means you multiply by 1/2 and you get 5 pi twelfths, and divide by 2, you get a pi n here. And this is n is an element of a set of integers. And so these are all solutions. And if you want specific solutions, we have n is an element of the set of integers. The set of integers, 0, plus or minus 1, plus or minus 2, etc. You just choose values of n that are integers. If I let n be 0, then I get my pi twelfths and my 5 pi twelfths. If I let n be 1, I get pi twelfths plus pi, which is going to be 13 pi twelfths. And I get 5 pi twelfths plus pi, and I get 17 pi twelfths. So if I want to get all angles from 0 to 2 pi, I have to just let n be 1, let n be 2, let n be 3 until I go over 2 pi, which is over 24 pi twelfths. And so from 0 to 2 pi, those are my 4 places where the sign of 2x will be 1/2. If we go back to Desmos, and I turn this off, turn that off, and go back to 2x, these are the places from 0 to 2 pi where it's 1/2. And we were able to get that analytically by that process. Questions on that? All right, so then they didn't ask for solutions from 0 to 2 pi, so they want all solutions, and these will generate all solutions, both to the right and to the left. It just, we can let n be a negative 100, and you're going to get another place where you get 1/2, yes.
How did you get 2x equals pi 6 and 2x equals 5 pi 6?
It is just that this is my angle, and so just think of this as theta, and what angles is sine 1/2?
Oh, okay.
Pi 6 and 5 pi 6.
Oh.
But since it's not actually just x, it's 2x, we start with the 2x here and then divide. But you need to notice the order of this. You write the infinite solution set before you divide by 2. That's important. All right, so solving a multiple angle. Here we go. Well, we want to get the trig function with the multiple angle by itself. And then you need to figure out for what angles is cosine going to be root 3 over 2. And it's going to be a quadrant 1 and a quadrant 4 angle because cosine's positive in 1 and 4. And so we want where x is root 3 over 2, and those, once again, are my 30-degree reference angles because you go the long leg to the right, and you're up 1/2. You go the long leg to the right, here you're down 1/2. So the two angles, so 2x represents the angle, and one of them is your pi 6, and then the other one is your 11 pi 6. So you have to be able to know for what angle is the cosine root 3 over 2. And so then we are going to go plus 2 pi n and plus 2 pi n here. So you write the infinite solution set before you divide by 2. And then when I divide by 2, it's the same as multiplying by 1/2. You get a pi twelfths and plus pi n. And here you get 11 pi twelfths plus pi n and an element of the integers. And if you want to generate where these, the different angles, you replace n with 1, -1, 2, -2, etc. And it generates all these places where when you double the angle, you get √3/2 for the cosine of it. And I have that set up here where we've got √3/2, which is about 0.866, and the cosine of 2x, and we'll turn off the others. So here's cosine. And if I can get it, there's pi 12ths, 11 pi 12ths, 13. Oops, I bumped it. Those are the 4 places. You get 4 places from 0 to 2 pi. And those equations will generate these values. And if I put -1, -2, I'm going to get these. So it gets you all these solutions for where the cosine, when you double that angle, you get √3/2. So anyway, this right here, these are your answers for all numbers. So then we see this note. For sine, cosine, cosecant, secant, always find all angles from 0 to 2 pi and add 2. Here it's 2n pi. I write 2 pi n. Doesn't, same thing. But for tangent and cotangent, their period is pi. So for tangent and cotangent, you just find the one angle in quadrant 1 or 2 that makes it true, and you add pi in, because its period's pi. So that's important. All right, so on the back side, we have solve this, and the idea is to isolate the trig function. And we have tangent 3x equals -√3. And so I'm going to be picking angles in quadrants 2 and 4 because tangent's negative in 2 and 4. And I know it's a 30, 60, 90 triangle because of the radical 3. And if I want it to be -√3, well, I need to have it where I have the √3/2 on the top and the 1/2 on the bottom, because that's what simplifies to √3. And tangent is y/x, so that means I'm looking for the ordered pair where the absolute value of x is 1/2 and absolute value of y is √3/2. So where we get 1/2 is when 1/2 is the short leg. So when I come back, this is -1/2 up √3/2. And then that's the only one that I actually need because the period of tangent is pi. When I add pi to it, I'm going to get the other angle and pick up the angle in quadrant 4. So I only need the one angle for tangent. And so I'm going to write, that's my symbol for the angle. And I am going to write the one angle where tangent's going to be -√3 in quadrant 1 or 2, and that is 2 pi thirds. But for tangent, then I do plus pi n. And that, when I add pi to this, that gets me the 5 pi thirds. And then the amount of rotation between those angles is always pi, because the period is pi. Now divide by 3, which is the same as multiplying by 1/3. and n is an element of the set of integers. And you can write it that way. You can write it where you put the n in the numerator of the fraction. It doesn't, I mean, it's the same thing. And then find all solutions, cotangent of x halves equaling 1. Again, isolate the cotangent. And when it's x over 2, your b is 1/2, and the period's actually going to be lengthened. It's going to get longer, so you get fewer solutions in a full rotation. But the process is exactly the same. You set the angle here, and you need for cotangent the one spot in quadrant 1 or 2 where the cotangent is 1. And tangent and cotangent are 1 at the 45-degree reference angle because x and y are the same. And it's positive in quadrant 1, so that's the angle that I need, is the 45-degree angle. And so I get pi 4s, but because it's cotangent, that's the only angle I need, and then plus pi n. And we'll get the n as an element of the integer at the end. But now you need to multiply by 2. You need to multiply by 2 to solve for x. And so you get pi halves plus 2 pi n. N is an element of the integers. And so then, for example 4, we'll just go ahead and do it together here. It's cosecant of 4x equaling 2. Now, for cosecant, the reciprocal of cosecant is sine. So I'm going to get, if I make it sine of 4x, then it's where sine is 1/2, the reciprocal. And I think that's easier to solve. So cosecant, the reciprocal is sine, so I can make it sine and flip the fraction, and those are going to be the same, you're going to get the same answers. And so then 4x is equal to, and for sine then, it's positive in 1 and 2. And sine is 1/2. We had this just on the front, didn't we? It's going to be at your pi 6 and your 5 pi 6. That's where y is 1/2. So I have a pi 6 and a 5 pi 6. And then you add 2 pi n because the period for cosecant is 2 pi n, and so it is for sine as well. And then divide by 4, which is multiplying by 1/4. And then don't forget, n is an element of the set of integers. And those are all solutions. So part of when you study for the test, when you're studying for the test, you need to distinguish this process when the angle is not just an x. You've got to compare and contrast, and remember, when you don't just have an x, this is how you need to do the process. You've got to study that. And that's it.